Today we're going to talk about factoring quadratic expressions. So this is a really important skill to learn. We will use this throughout all of Algebra 2. So be sure that if you are confused about anything, you ask questions. So we have a couple of vocabulary words, actually one really vocabulary word. We have greatest common factor. This is also known as GCF. It is the biggest number that can divide two numbers. Now, it's not really a great definition, but it works better if we have an example. So, between 6 and 36, the largest number that can be divided by each of those numbers is 6, okay? 6 divided by 6 is 1, and then 36 divided by 6 is 6, okay? Now, you would think, well, 36 is the largest number, but you cannot divide 6 by 36, okay? So another example is 4 and 12. So the greatest common factor there is going to be 4, because 4 will divide into 4 evenly, and 4 will divide into 12 evenly. Okay, so that's what a greatest common factor is. We can use greatest common factor to factor out these expressions. Okay, so if I look at this first example here, x squared plus 2x. Now, I hope you know what this squared means. It means that there's two x's there, and then plus 2x. So the greatest common factor here is gonna be an x. So if I divide each of these terms by x, what do I have left over? Well, if I have x squared in the top, so I have x times x divided by x, that means I can cancel one of them, and I'm just left with x. If I divide 2x by x, the x's cancel, and all I'm left with is 2. So that is factored, okay? I have my greatest common factor out here, and then what's left over is inside the parentheses. Okay, so let's look at the second one here, 4x cubed plus 6x squared minus 8x, I'm sorry. So first let's look at the numbers. Between 4, 6, and 8, what is the greatest common factor that goes into all of those? Well, 2. Okay, now let's look at the variables. I have x cubed, x squared, and x. So if you look at the last term there, that will tell you how many x's you can take out. Okay, so since there's only one there, I can only take one x out. So if I divide each term here by 2x, what I have left over will get written inside parentheses. So 4 divided by 2 is 2. X cubed divided by x is x squared. 6 divided by 2 is 3. X squared divided by x is x. Minus 8 divided by 2 is 4. X divided by x is 1. Okay, so that's our factored form there. So now let's look at factoring trinomials with a equal to 1. So a trinomial has 3 terms. So up here you can see 1, 2, 3. And the a value right here is 1. Okay, so I have an example here. X squared plus 9x plus 20. And I've given you the steps off to the right. So first things first, always look for a greatest common factor. Sometimes you will see that there's a greatest common factor, and that will save you a headache later, okay? So between x squared, 9x, and 20, there is no greatest common factor, so we continue to step 2, which means multiply a times c. Well, my a value here is 1, so I will multiply 1 times 20, which is 20. The next step is to find two factors of A times C that will add to B. So what I want to do is I want to find two numbers that multiply to 20 but will add to 9. Okay, so let's just go through some factors of 20. So 1 and 20, I add those together, I get 21. Not gonna work. 2 and 10, I add those together, I get 12. Not gonna work. 3 is not a factor of 20. 4 and 5, if I add those will give me 9. So these, I call them magic numbers. Okay? So the way that you set up your factoring is you have two sets of parentheses and you put an X in front, in the very front. Then you will plug in your magic numbers. So since they're both positive, you will have a plus sign in between. Okay? So this is your factored form, x plus 4 and x plus 5. Okay? So factored form, right there. Now, to check your answer, you use FOIL. So let me get a different color here. If we FOIL these, well, x times x is x squared. X times 5 is 5x. 4 times x is 4x. And then 4 times 5 is 20. If I combine like terms, I do get my original equation. Therefore, this works. Let me show you another example of factoring a trinomial. We have negative x squared plus 13x minus 12. Now, if we look at it, my a value here is not 1. It's negative 1. But remember what I said, always look for a greatest common factor first. So if you have a negative out front here, I highly recommend that you factor it out of everything. So if I factor out a negative, it would be like I'm dividing each of these by -1. So the sign will change for each term. Okay? So now I am going to factor this guy. Now the a value is 1. Okay? So I multiply a times c. Well, 1 times 12 is 12. I look for magic numbers that will multiply to 12 but add to -13. So if they're adding to a negative number, they have to be negative, okay? If they multiply to a positive and add to a negative, then the two numbers must be negative. So let's go through factors of 12. Let's do -1 and -12. Well, if I add those two together, ding, 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 there's my magic numbers, okay? So I'm going to take this negative and just keep him around. I'm going to set up my factored form here, put an x in front of both parentheses, and then I plug in my magic numbers with the sign. Okay? Again, last step, check using FOIL. So I'm going to FOIL this guy right here. So x times x is x squared. X times -12 is -12x. -1 times x is -x. -1 times -12 is +12. I simplify my expression here. Now remember that you do have that negative on the outside, so you can distribute that guy in, and you should get the answer that you started with. Okay? Okay, so now let's talk about factoring trinomials whenever a is not 1. So these can be a little tricky. There's one surefire way that will work every single time, but it's a little weird, okay? So I'm going to show you two methods to factoring when a is not 1, and you can choose which one you like. But first things first, always try to find a greatest common factor first. If you cannot find a greatest common factor, then you need to proceed with one of these two methods. Okay, so the first one I'm going to show you is the box method. Its steps are a little complicated. This is not my favorite thing, but I will show it to you anyways. So we have 3x squared minus 20x plus 28. So my a is 3, my b is negative 20, and my c is 28. Okay, so the first step is to set up your box. Okay, so here's my box. Now, this first term here is going to go right there. So you're going to write 3x squared. This last term is going to go down here. So you have 28, and then put an x and an x in each of the missing boxes. Okay? So now, step 2 is to multiply a times c. Okay? So over here, 3 times 28. So that is 84. And then step 3 is just like normal factoring, so you're going to find your magic numbers. So two numbers that will multiply to 84, but add to negative 20. So again, they're multiplying to a positive and adding to a negative, so they both need to be negative. Okay, so let's start going through some factors of 84. So let's see, negative 1, negative 84. That's not going to work. Negative 2 and negative 42. That'll give you negative 44. It's not negative 20. That's not going to work. Let's see, negative 3 and negative 28. What'll that give you? Negative 31. Okay, we're getting closer to negative 20, but not quite. Negative 4 and negative 21. That'll give you negative 25. Still not going to work. 84 is not a factor of 5, so let's look at 6. So negative 6 and negative 14. Those are your magic numbers, okay? So if I put it doesn't matter which place you put your magic numbers in, as long as they both go in. So I'm going to put negative 6 and negative 14, okay? Now, what I'm going to do is I'm going to pull out the factors of each row. So if I look at this row here, what is my greatest common factor between 3x squared and negative 6x? So 3 and 6, greatest common factor is 3, and I can factor out an x. Now, if I factor out a 3x from 3x squared, I'm going to get x. If I factor 3x out of negative 6x, I get negative 2. Okay? So now I'm going to check the second row. Again, if you have a negative in front, definitely factor that out as well. So between negative 14x and 28, my greatest common factor is going to be negative 14. Now, if I factor out a negative 14 from negative 14x, I'm just left with x. If I factor a negative 14 out of 28, I'm left with negative 2. So now if you look here, you should have x's in both columns now. So you can write an x up there, and you should have a negative 2. So these right here are your factors. So you have x minus 2 and 3x minus 14. So I'm not a fan of the box method, but I love the berry method because it works every single time. So the berry method is a little weird. First, always check for your greatest common factor. If you don't have one, look at your A value. Whatever your A value is, that is your berry. So our berry is 3. So now I'm going to follow the same steps as the box method. So let's see. So step 1, let's just identify our steps here. Find your berry, which was 3. Step 2, we are going to multiply A times C. So 3 times 28, again 84. Step 3, find your magic numbers. And we've already found them in the box method. It was -6 and -14. Okay? So now, whenever I set up my factoring here, normally I would just put an X. But now, I'm going to go ahead and put that berry in front of each one. Okay? Now I plug in my magic numbers with the sign. Okay? So, if I were to FOIL this, 3x times 3x is not 3x squared. So I have to factor out a 3. You have to factor out a berry. So if you look at the first term here, 3x minus 6, I can factor out a 3. I'm left with x minus 2. Now, once you have already factored out your berry, you leave the rest alone. Okay? So now, last step, you eat your berry. It goes away. It goes into the math black hole. And your factored form is x minus 2 times 3x minus 14, which is exactly what we got with box method. So I want to show you one more example of factoring trinomials when a is not 1. So I have 2x squared plus 11x plus 12. So again, check for greatest common factor. There's not one. So I want to show you box method first, and then I'll show you berry method. So box method, I'm going to set up my box. So the 2x squared is going to go in the first spot there, and the 12 is going to go in the last spot, and then you fill in with your x's. Now remember, your next step is to multiply your a times your c. So I will have 2 times 12, which is 24. Now I need to find magic numbers that will multiply to 24 but add to 11. Okay, so let's just go down the line. 1 and 24, that gives you 26, not gonna work. 2 and 12, that gives you 14, not gonna work. 3 and 8, there you go. Those are your magic numbers. Okay, so you can plug them in. Now remember, you're gonna factor out your greatest common factor from your rows. So 2x squared and 8x, my greatest common factor is going to be 2x. So if I factor out a 2x from 2x squared, all I'm left with is x. If I factor 2x out of 8x, all I'm left with is 4. Okay? You're going to do the same thing with 3x and 12. Your greatest common factor is 3. If I factor a 3x out of, if I factor 3 out of 3x, I am left with x. If I factor 3 out of 12, I am left with 4. So that's my second factor. So my factored form here is 2x plus 3 and x plus 4. Now let me show you the berry method. So your berry is going to be your 2. Okay, so remember, you multiply a times c, so 2 times 12 is 24. You find your magic numbers, which we've already found to be 3 and 8. You set up your parentheses and you put your berry in front of the x in both of them. Then you plug in your magic numbers. So now we need to factor a 2, or our berry, out of one of these factors. So if I look at this first one here, 2x plus 3, I can't factor out a 2. If I look at the second one here, 2x plus 8, I can factor out a 2. So if I factor a 2 out of 2x plus 8, I'm left with x plus 4. Now, the weird part, once you factor out your berry, you eat it. It goes away. So your factored form is 2x plus 3 times x plus 4. Last but not least, let's talk about difference of squares. So a perfect square are numbers like 1, 4, 9, 25, 16, 49, 121. It's a number that you get by multiplying a number by itself. So 9 is a perfect square of 3. 25 is a perfect square of 5. 1 is a perfect square of 1. Okay? So it's really important to identify these perfect squares. So difference means subtraction. So in order to factor a difference of squares, your two terms have to be perfect squares, and there has to be a subtraction sign in between. Otherwise, this won't work. So if we look at x squared, so x squared is a perfect square. It's a perfect square of x. Okay? 9 is a perfect square of 3. So the factored form here is you are going to have x plus 3 and x minus 3. Okay? That's how you factor difference of squares. If I look at this second one here, 25x squared minus 49. So 25 is a perfect square of 5. X squared is a perfect square of x. And 49 is a perfect square of 7. So my factored form is 5x plus 7 and 5x minus 7. And that's how you factor difference of squares.